What if Earth isn't the only cradle of life? Scientists have found planets with liquid water, Earth-like atmospheres, and even potential alien biospheres just waiting to be explored. To host life, a planet needs more than just water. It must lie in the habitable zone, have a stable atmosphere, and possibly geothermal activity or magnetic protection. The Goldilocks zone is the sweet spot, not too hot, not too cold, where liquid water can exist. Earth sits perfectly in this zone. But so do several exoplanets. But there's more to it. A protective atmosphere, rich in carbon dioxide and nitrogen, helps regulate temperature and block harmful radiation, key for sustaining microbial life. Some planets generate magnetic fields, shields against solar wind. Earth has it. So do some gas giants' moons. Without this, life could be stripped away by space weather. Liquid water, organic molecules, and energy sources, these three ingredients form the cosmic life triangle. Scientists use this formula to scan thousands of planets for signs of habitability. Let's start with Kepler 452b, often called Earth's cousin. It orbits a sun-like star and is about 1,400 light-years away in the Cygnus constellation. Kepler 452b lies in the habitable zone and may have volcanic activity, which can recycle nutrients and create stable climates, a key factor for advanced life. Next, TRAPPIST-1e-, part of a 7-planet system just 39 light-years away. TRAPPIST-1e is the most Earth-like, with potential liquid water and temperate conditions. Unlike Earth, TRAPPIST-1e may be tidally locked, meaning one side always faces its star, but the twilight zone between day and night could host life. LHS 1140b is a super-Earth about 41 light-years away. It's larger and more massive than Earth, with a dense atmosphere that could trap heat, ideal for life. LHS 1140b likely has volcanic activity, which recycles carbon dioxide and drives climate systems, key ingredients for supporting biospheres. Meet Proxima Centauri b, the closest known exoplanet to Earth at just 4.2 light-years away. It orbits Proxima Centauri, a red dwarf star. Proxima b may be tidally locked, but simulations suggest habitable temperatures could exist in its terminator zone, where day meets night. What makes Proxima b fascinating? Its star occasionally flares, which could impact its atmosphere, or possibly spark evolutionary leaps like UV-triggered mutations. Now let's look at K218b, an ocean planet with signs of water vapor in its atmosphere. It's a strong contender for alien microbial life. K2-18b may host hydrogen-rich atmospheres and possibly biosignature gases like methane or ammonia, clues that life could thrive below cloud layers. Scientists speculate that its thick atmosphere might support hydrothermal life, similar to deep-sea vents on Earth, far below sunlight. Gliese 581g, once dismissed as a false positive, is back in debate. If real, it sits in its star's habitable zone and may have rocky terrain. Gliese 581g is larger than Earth and might have low axial tilt, meaning stable seasons, important for long-term climate stability. If Gliese 581g supports life, it might resemble primitive microbes or fungal ecosystems, organisms that thrive in thin atmospheres and dark soils. Let's not forget Tau Ceti F, located just 12 light-years away. It's in the outer edge of its star's habitable zone, with potential for cold-adapted life. Life here might resemble Arctic extremophils, creatures that thrive in cold, high-radiation environments, like those near Earth's poles. Many of these planets orbit red dwarf stars, which are long-lived and stable. That gives alien life billions of years to evolve. But some scientists warn that red dwarfs are active and can emit flares that might strip away atmospheres or hinder life's survival. Despite challenges, these planets offer our best clues so far. The variety of worlds, rocky, icy, ocean-covered, suggests life may adapt in unexpected ways. Planets aren't the only candidates. Some moons, like Europa and Enceladus, could harbor life in subsurface oceans beneath icy crusts. Europa, one of Jupiter's moons, has plumes of water vapor erupting into space. Could these jets carry signs of alien microbes? Saturn's moon, Enceladus, also has active geysers. Scientists have detected complex organic molecules in its vapor, potential precursors to life. Some planets might be ocean worlds, completely covered by water. K2-18b could be one. If its ocean isn't too deep, light might still penetrate for photosynthesis. Our own solar system hides potential life, not on planets, but on moons. These ocean worlds may hold vast subsurface seas. Take Europa, moon of Jupiter. Under its ice, there's a global saltwater ocean, warmed by tidal forces from the gas giant. Europa's ocean may have hydrothermal vents, just like Earth's deep oceans, perfect places for chemosynthetic life to evolve. Next is Enceladus, Saturn's moon. It ejects geysers of water vapor and organic molecules, direct evidence of chemical activity below. NASA's Cassini spacecraft flew through Enceladus plumes and detected methane, a potential sign of biological processes beneath the surface. Let's not forget Titan, also orbiting Saturn. While frigid, it has liquid methane lakes and complex organics in the atmosphere. Though its lakes are made of hydrocarbons, scientists think non-water-based life might evolve there, radically different from Earth life. Even dwarf planets like Ceres and Pluto may hide briny oceans below icy shells. Our solar system might be more alive than we thought. NASA's James Webb Space Telescope is changing the game. It can analyze atmospheres of distant planets for gases like oxygen and methane, possible biosignatures. Biosignatures like methane, ozone, and chlorophyll colors can hint at photosynthetic life. The more we scan, the higher our chances of detecting life. Some scientists even suggest listening for technosignatures, signals from alien technology like radio waves or laser pulses. To find life, scientists study biosignatures, chemical traces like oxygen, methane, and ozone in exoplanet atmospheres. Enter the James Webb Space Telescope. It's already analyzing atmospheres of distant worlds for clues of habitability. Webb recently studied K2-18b and hinted at possible dimethyl sulfide, a gas that, on Earth, comes from phytoplankton. Future missions like LUVOIR and HABEX could directly image Earth-like planets and hunt for surface-level biosignatures. SETI continues listening for radio signals from advanced civilizations, but now also uses machine learning to detect hidden patterns. Some researchers explore technosignatures, artificial light, satellites, or industrial gases, as evidence of intelligent life. Others ask, are we looking in the wrong place? Life might exist in forms we can't yet recognize, based on silicon, ammonia, or even plasma. The biggest shift? We now think the universe is likely teeming with life, and it's only a matter of time before we find the first sign. We may not have found alien life yet, but the evidence keeps building. In a universe with billions of planets, it's not a question of if, but when.